tonight. Tonight we have from Robb Kaler's basement. Is that right? The basement in Anchorage.
Over by the airport.
Right. Tonight's Straight Science. Straight Science is an evening presentation series put on throughout the year, co-hosted by Alaska Sea Grant and UAF Northwest Campus here in Nome. And Robb Kaler, he serves as the U.S. Fish and Wildlife Service Seabird Specialist in Anchorage, which means he's in Anchorage, but he serves all over Alaska. And he also manages the North Pacific Seabird Colony Register. So this one ought to be pretty interesting for all of us. Since 2017, the Bering Strait region has witnessed the mysterious die-off of seabirds. What does it take to find answers? So Robb's going to provide an overview of results from all the partnerships that have been working on this situation out here, and tell us where we are and where we're headed. With that, thank you, Robb. Take it away.
All right. Well, thanks very much for hosting this. My opening slide here has a list of a lot of folks, and as the title says, partnering and search for answers requires a lot of partners. And so the banner across the bottom is just some of the icons or logos for these partners, but I've listed some of them. So I'm Robb Kaler, and I work with Kathy Kulitz and Liz Lubunsky based in Anchorage. Heather Renner, I'll be using some of the information from Alaska Maritime National Wildlife Refuge. So they do the monitoring for seabirds and across the Alaska Maritime National Wildlife Refuge, and then compile some of the other refuges. Barb Bodenstein and Bob Dusick, National Wildlife Health Center, they're based in Madison, but they're USGS, and they've really been helping on getting the physical examination of carcasses that we've been getting from folks like Gay. And so Gay is on the next one. Of course, UAF, Alaska Sea Grant, and then Brandon and Austin Amasuk from Coeric have been huge in getting carcasses submitted, but as well as reports from communities. So again, I'll keep emphasizing the partner piece of this, and really it's with the partnership that I'm allowed to work in my basement in Anchorage and then still come up with some kind of compiled information that we can share back into these communities. And so Stasha Backenstow and Heather Coletti are with National Park Service, and they've been really key partners for Cape Krusenstern and the Bering Land Bridge National Monument and Preserves. And then Julia Parrish, Tim Jones, and Hillary Burgess are based at University of Washington, but they do a coastal observation and seabird survey team citizen science project that helps kind of provide us with long-term background information on beached seabirds. And then have been key partners in helping consolidate some of the reports that we get from Gay and Brandon and other community members, kind of putting it in that broader geographic spectrum or view. And then Caroline Van Hemert, Matt Smith, and Sarah Shane are at the USGS Alaska Science Center, and they've been doing a lot of the harmful algal bloom work that I'll be talking about. But again, just to reemphasize that the banner across the bottom, there's a lot of tribal communities and partners, as well as our federal and state partners as well. So this is kind of just a quick background slide. As Gay mentioned, I've been leading the response for seabird die-offs pretty much since 2015-16 when we had the Gulf of Alaska die-off. And since then, I've been coordinating getting reports as well as getting carcasses submitted to the National Wildlife Health Center in Madison for examination, disease testing, and I'll go into that a little bit. And these are a couple links on this screen that are linking to Fish and Wildlife Service sites that we have. And then I also manage the North Pacific Colony Register. So that's one of the other things that I do. And then the numbers and email here are also just to provide, you'll see this phone number a couple times through this presentation as we're trying to get more reports from the coastal communities. So I generally start with a very attractive picture of a tufted puffin. This is, we describe it as the Harley Davidson of seabirds in Alaska. The golden plumes kind of give it a tough appearance. But I often just say, well, we monitor all marine birds, all the birds that are interacting either offshore, near shore, or even in lagoons. And so I use the term often for marine birds, and that includes the gulls and herons, loons as well. And so we really try to monitor all of this and just use them as indicators of the marine system, the health of the ecosystem. And just as a brief background, the penguins occur in the southern hemisphere, but they're kind of the equivalent, if you look on the bottom, to our murs. And that's in the chorogiforms, and that includes the gulls, terns, and the auks, auklets. You got puffin there. And then the pelicaniforms, we've got the cormorant. And I'll talk about the proceliforms, essentially the albatross, fulmars, and storm petrels, also known as the tube noses and ocean wanderers. They move great distances with very effortless flight. And as a background, why are we so interested in seabirds in Alaska? The quotation in the lower right, I think, summarizes what I've got several bullets laying out. Seabirds live long, they breed later, that is, come to maturity later, and overall, compared to other birds, have fewer offspring. So that kind of suggests that they're a case-selected species. So some of the albatross will live over 60 years, but they don't necessarily start breeding until they're 5, maybe even as old as 10 years, so very delayed. And seabirds are colonial nesters for the most part, many of them nesting in large colonies on ledges, as well as burrows, and I'll show a little bit of that. But they only lay a single egg per year, so by the time they're 3 or 4 and then start breeding and perhaps make it to 15 to 20 years of age, they've not had a lot of opportunity to produce, but their young are usually have good success fledging from the nest. Now, juveniles making it to their breeding age, we have less information about, but in general, overall, they have very low breeding potential. And then specifically to Alaska, 75,000 or 75% of US seabirds, that's North American seabirds really, breed in Alaska. So Alaska is a very seabird rich state. We have over 38 species that nest in Alaska with over 1,300 colonies. So I mentioned that I also administrate the North Pacific Seabird Colony Register, and that's kind of seabird biogeography. Who is breeding, how many, and approximately where. But keeping an eye on how reproductive success is, as well as population trends and productivity trends over time is a lot more challenging. So the colony register, again, is just biogeography, where, who, and an estimate of how many, but not necessarily used for population trends. And then just kind of bring the message home, monitoring seabirds in Alaska, as I mentioned, they're indicators of the marine ecosystem. They depend on the ocean for food and actually only come to land for about a quarter of their annual life just to breed. Otherwise, they spend their entire time on the ocean. And so compared to fish and marine mammals, they're much easier to study and monitor those population and productivity trends. And they like to eat fish. So common prey of seabirds, and the top ones, Pacific sandlance and capelin, are nutritionally rich nutrient content. But there's good years and there's bad years, kind of cyclical up and downs. And then for capelin in particular, since the Bering Ocean has gone from 1976, 1977, from a cold ocean, as it's been referred to, going to a warm ocean. So that's been, fish are very temperature sensitive, and so that's had a lot of changes. And with those changes, examples like juvenile walleye pollock, lower quality prey, less nutrient rich, and those numbers increased after that 1976, 1977 regime shift, where the Bering went from a cold ocean to a warmer ocean. And so euphausids, the zooplankton, copepods, make up a big portion of their diet, but we don't know as much about that as we do to what we know they bring back, what the seabirds are bringing back to their ledge nesting chicks, for example, which are these sandlance and capelin, greenling, Atka mackerel. But we assume, based on stable isotope analysis and fatty acid analysis, that they're consuming a lot more euphausids than we give them credit for. And then just as an example, the metabolic rate for a common murre, which weighs a little over 1,000 grams, they need to consume somewhere between 10 and 30% of their body mass daily. And that can be anywhere from 90 to 300 fish. So that's a lot of fishing. And unlike me, I go fishing, I don't do a lot of catching. So it's fishing and actually catching. So these birds have to work pretty hard to maintain their metabolic rates. And then a little bit more information about common and thick-billed murres. They nest in very large colonies, anywhere from hundreds to hundreds of thousands. And one adaptation is an egg that's shaped like a pear or a light bulb. So if they do get flushed by a predator, whether it's a peregrine falcon or an eagle, that when they flush off that colony, the egg will generally loop in circles rather than roll off the cliff. So that's one of their adaptations. And then, as I mentioned, least and crested auklets, burrow nesters, so puffins are as well burrow nesters. They're very difficult to monitor because they come back to their breeding colonies during the breeding season during dawn and dusk. I think some of the ideas is to perhaps use a marine band radar, put it out in front of these colonies, which in these photos here, you see that there are just clouds of birds coming and going. So really difficult. People will estimate, and these are people that have been looking at these colonies for many years, but estimating 3.2 million least and crested auklets out of this cloud is really quite challenging. So some of the things we might be moving to is using a marine band radar, perhaps in the Bering Strait region, that gets deployed for 7 days, just so you can at least get an index of birds coming and going, but very impossible to actually get a confident number of birds at a colony. Perhaps, Little Diomede, of course, has many colonies, and very hard to actually determine a number. And then, so this figure here is a cladogram showing relationships based on genetics between all these birds. There's about 22, and the top are the common murres and thick-billed murre. They're related to the East Coast dovekey and razorbill. Merlets and guillemots after that. And then we also have the marbled and kitlitzes and thick-billed, but they're all very interesting birds, and that quotation on the side, a highly specialized, ecological, diverse group of marine wing-propelled pursuit diving birds. Essentially, these guys are eating plankton and fish and working very hard, and so they're very interesting, and I've been really excited to be able to call it myself a seabird specialist. Their life history strategies vary from precocial young, but once they hatch, they're mobile with their parents, to semi-precocial, where they're actually in the nest for over 60 days, getting tended by their parent, which of course takes away from a parent's future breeding abilities. And then one of the other things that we have seabird-wise in Alaska are birds that don't actually breed at our colonies, but they come up from either the tropical Hawaiian Islands or as far south as the Southern Hemisphere, Australia and New Zealand. And these are the shearwaters and albatross. And the shearwaters come up to the Bering, for example, during their non-breeding season, but they really dwarf the numbers of other seabirds by sheer numbers. Anywhere, 400 birds per kilometer squared is not an unusual thing at the peak in June or July. And then Laysan albatross, black-footed and short-tailed. Short-tailed actually nest in Japan, and then they come up to our waters on foraging and then return back to their nests. So long-distance migrants just for food. So they'll do these movements every few days. And so the non-breeding, really the shearwaters, we have two species, sooty and short-tailed, and they're very interesting, and really, again, as I mentioned, dwarf the other birds that we have at sea in Alaska. And so one of the species that is quite interesting, and I mention it because in 2019, we had a very large die-off of shearwaters in Alaska. And so in addition to monitoring the die-off events, we also do AtSea Monitoring. And this slide, so Kathy Kulitz and Liz Lubunsky lead the AtSea surveys, essentially putting observers on different vessels, Coast Guard, and this is Bureau of Ocean Energy Management support the funds for this, North Pacific Research Board, NOAA, UAF, National Science Foundation. So there's a lot of partners putting a Seabird observer onto a vessel that's doing other at-sea work, oceanography research. This is just one more level of information that we have and can contribute. And unfortunately, this slide kind of shows that there's not a lot of surveys happening this year due to COVID. And in addition to that, and I'll get into the colony monitoring that's also done by Fish and Wildlife Service, but that land-based work has been completely canceled for 2020. So unfortunately, we're going to have a gap in the information for the year 2020 for seabirds productivity, as well as some of the distribution information. So this slide just kind of talks a little bit more about the at-sea surveys, but really putting observers on Coast Guard vessels or NOAA vessels has added a layer of information. They use a 300-meter wide transect and essentially counting marine mammals and marine birds and contributing those data to the North Pacific pelagic seabird database managed by the USGS, but really informing a lot of, or providing a lot of information to planning efforts like Bureau of Ocean Energy Management, and being able to inform also distribution changes. And so the map on the left demonstrates some of the transects that have been done over time. And so this program was really stood up doing the at-sea work in 2006 and 2007 and has been ongoing annually since then. And so it really helps develop a distribution map. And so the two figures on the right show thick-billed and common murres, and it's a heat map. So the darker polygons indicate higher densities. And so over time, you can look at changes in distribution of these birds, which with given changes in the climate and the ocean temperatures, you can see birds readjusting their distribution or their ranges. And I like to use this slide. I've heard that what happens in the Arctic doesn't stay in the Arctic, but when I look at this figure showing currents, ocean currents, it shows me that what happens in the Bering Sea or the North Bering doesn't stay in the North Bering. It actually goes up to the Arctic. And so I think that's really something that I try to emphasize to my leadership with regard to why we're interested in monitoring the Bering Strait. And of course, you folks in the Bering Strait region already know this, just something we need to reiterate and emphasize to our leadership. And so I'm going to actually, this is from Kathy Kuwitz, my supervisor. And really what this is demonstrating is that, and I'm going to, forgive me for reading her text here, but overall decline in abundance of the fish-eating birds, so like the murres, in both the Chirikov Basin and Northern Bering region for St. Lawrence, in contrast to the diving plankton, mainly least and crested auklets, that had actually increased in the Northern Bering. So in recent years, they do not appear to have moved into the Chukchi after the breeding season as they had in the past, and actually perhaps didn't breed at all or failed early in the season. So we really don't know, but these are some of the changes and shifts that we are seeing using these at-sea data. And then the next slide provides a little bit more. So thick-billed murres, so increases here are in the red and decreases are indicated in blue, the colder temperatures. And so in the Bering and Chukchi, there's been an increase in the last 3 years. And then least auklets in the Chirikov Basin, as I mentioned, perhaps failing at St. Lawrence Island. I think that's some of the information that Alexis Will and Sasha Kataisky at UAF did a Bering Strait presentation on. And then shearwaters have increased in the Chukchi. Again, the shearwaters being a species that come up from the northern or the southern hemisphere. But looking at these, the piscivores have increased, the planktivores appear to have decreased or also increased in the Chirikov moving further north. And then the shearwaters also increasing. And the shearwaters are more omnivorous. And again, the partners that have contributed to collecting this information, the banner across the bottom, have been really key. Very hard to get at-sea observers into the ocean without a large vessel. And so this slide is from the Alaska Maritime. So we've got several refuges that collect colony data, and that's colony monitoring. So this is the terrestrial counterpart to those AtSea surveys, looking at population trends, reproductive or population success. We can also look at diet by taking pictures or getting food from adults bringing prey back to their chicks, either at the burrow or at the ledges. The phenology, the timing of that breeding, and then overall adult survival. And so the map on the lower right kind of shows the way Alaska has been broken up. And some of these sites actually have annual attendance. Of course, not in 2020, as I mentioned, but these have long-term camps that have been studied for over 30 to almost 40 years. And then other sites that are intermittently visited, getting a boom-bust reproductive success. So this all helps us keep a finger on the pulse of the ecosystem of the marine environment. And so this is from Alaska Maritime. This card, I've got 3 of these, and I'll just go through them very quickly, but across the top are the feeding guilds. So on the far left is red-faced cormorants, which are, if you look at the bottom, primarily fish eaters, glaucous winged gull, common murres, thick-billed murres, and then as you move right on this figure, it's to the primarily zooplankton consumers, so least auklets, parakeet auklets. And then the left side shows the Gulf of Alaska up north to Cape Lisburne, and so these are the different regions. And really, this is a really nice depiction that Alaska Maritime National Wildlife Refuge. But on the bottom, I've summarized the way above average. And so this is overall long-term productivity. And looking at in 2017, very low good productivity. And then average productivity around 40 and below average 40. But complete failure, which was largely unheard of prior to 2015. These birds are stalwarts, they might only lay a single egg, but they generally attempt to breed, every few years and be successful. So complete failure in 2017 was largely shocking and unusual for seabirds. 2018 is following up, and this is 54 or 54 sites. So going back one, notice that this is 52 sites that were monitored. And then in 2018 and 19 were 54 sites. And what I want to emphasize is, and I just go back and forth, and in 2019, you see a lot more smiles. So productivity had increased by 2019, better than 2018. And so this is just a quick figure, kind of productivity being on the left side, but in 2017 to 2019, you see that the great and the good breeding, the productivity increased, and the bad and the fail decreased. So that's a good thing to see. What's unusual is that in 2019 we had a large die-off of shearwaters as well as murres and puffins. So despite what we were seeing at the colony, where reproductive success at the long-term monitoring sites had actually gone up, we were still seeing a spike in unusual mortality events or mass mortality. And so this figure, as you can see, I'm starting to run out of room. I've been using this figure similarly since 2017, and I keep have to add another year, but essentially 2016, we had a murre die-off in the Gulf of Alaska, and it's only been annually occurring in both the Bering Strait and Bering region, as well as St. Paul, and then as far north as Point Hope and Uktiavik. So, but yeah, the point of this slide is we see that fulmars and shearwaters, puffins and auklets, murres as well, are all showing up on beaches. And I'll provide a little bit more detail, but these events are becoming annual, and their seabird die-offs are known to occur. They're well documented in the literature. They even have a euphemism called wrecks. A seabird wreck is when you have a mass mortality event. But the fact that these are happening annually is very reason for concern. And this is a quick summary. So 2017, and this is focused on the Bering Strait region in particular, but the figures across the top, and if you if you see, we've gotten a little bit more sophisticated in our figures, but the far left is 2017 die-off. Those concentric circles indicate by size of circle the number of birds that have been reported. And so you see what's unusual is both the geographic extent, and in the 2017, it's not as clear, but the duration, the time that these reports continue to be coming in. And then so 2018, you see it's broken out by month, May, June, July, into August, and then you see the concentric circles, so a large die-off at Gamble on St. Lawrence Island in June, and you might not be able to see, but that was 94% thick-billed common murres, and the total, the N size is on the side there too, and I've summarized it, but 2019, again, we started getting phone calls from Brandon and Gay, started in May. It moved into the Bristol Bay region. A lot of folks fishing in the Bristol Bay started giving us reports, and these were largely shearwaters. So you see that in August, there was roughly about 5,800 short-tailed shearwaters reported, and those were largely from the Bristol Bay region. And then as you move through September, October, that die-off of shearwaters, which also included kittiwakes as well, and then some murres and puffins moved back to the north, back to the Bering Strait region. So this table just is by the time a seabird passes away, dies or drowns, washes up on a beach, and somebody comes along and actually counts it, but even more so, counts it and sends a report to either Gay or another community, tribal coordinator, and then we're able to get it in Anchorage. These are, that's what I'm emphasizing, is that these numbers of total reported are very minimum total numbers. And so as you see in 2017, we had 1,600 to a peak in 2019 of 9,000 birds. And we submit these to, so working with partners in the communities, getting fresh carcasses. These carcasses are submitted to the USGS National Wildlife Center in Madison, where they're tested and examined. So a physical examination as well as disease testing, looking for infectious and non-infectious disease, and really determining an overall cause of death. So we submitted with our partners helping us getting fresh carcasses, which then have to be frozen, which means they have to be in a biological freezer, and then overnight ship them to me in Anchorage, and then I overnight ship them to Madison. Quite an ordeal, but 2017, you see the National Wildlife Health Center, NWHC, so we've submitted, we really outdid ourselves in 2019 and submitted 63 carcasses. And so far in 2020, we've submitted 15. But as of right now, the majority of those causes of death is emaciation. So a lot of these birds, you could feel the keel bone, and they're also examined and tested for avian influenza. So there's a couple side stories here that I won't go into too much, but in 2018, there were 2 positive cases for H10N6, which isn't known to jump to humans, but one point to emphasize is that while we don't think the cause of death has anything to do with the disease, a bird that's starved becomes susceptible to infections, disease, which includes biotoxins perhaps. So the STX there is for Saxotoxin, and that's associated with paralytic shellfish poisoning. And that's something that we're also looking at. So as the ocean temperatures increase, so does the frequency of harmful algal bloom events. And so we don't really understand what level of concentration that might affect a seabird. There are those levels known for shellfish, but the commercial shellfish industry being very well monitored and tested for, we really don't know how it affects these birds. So the insult to injury is the birds having not been able to find food, perhaps due to competition with increased biomass of cod and pollock in the Bering Strait region, for example. And then they have exposure to a harmful algal bloom event, Saxotoxin, either through their food or other ways, and then making them weaken in their immune system. So a lot of angles that we're considering, and then of course this banner across the bottom, again emphasizing all the partners that are really helping make these maps and track these events over time. And again, the magnitude is really hard to determine how many. The numbers we have here are just a minimum number of reported carcasses, but we're also monitoring the duration. So we start getting reports. In 2020, it was in June, but we continue to get reports. And today we just got a report from Unalaska, which were accompanied with reports of sand lance washed up on the beach on the south side of Unalaska. So they have had high levels of PSP reported down from the Aleutians. So something to keep an eye on in the Bering Strait region. So let's see, I'm at 7:04. I'm going to take a pull of my tea. And just continue making my way through here. So 2020, as I mentioned, we started getting reports in June, and those reports kind of spiked in late July, and then just as of today, we got one from an Alaska report. So it's largely been horned puffins and murres, which are you know, piscivores, forage fish eating auks, and then right now we've been able to submit 15 carcasses to Madison, to the USGS National Wildlife Health Center. 12 of those were either in good enough condition to examine. Sometimes they've been opened and so not able to be used for disease examination. And then right now, all birds were in poor body condition. So it's leading us to believe that starvation again is the cause of death this year, but we also want to, you know, keep an eye on the infectious disease, which so far avian influenza has all come out negative. And then the Saxotoxin test is pending due to the COVID-19 and the USGS Alaska Science Center based here in Anchorage not being able to get into their lab. So the National Wildlife Health Center is collecting tissues to be examined for harmful algal bloom, saxotoxin and domoic acid, but right now. In addition to that, in about the 17th of June, there was a report of an oiling event, and it turned out it wasn't petroleum oil, but appears to be some kind of fish or vegetable oil. This did affect 8 birds were reported, I think a total of 10, and some of those were collected and sent to the USGS National Wildlife Health Center, as well as a sample of that oil. And so I'll give a brief update on that as well. But essentially, there's also been a report in Savunga, 18 miles. So the oil was 20 miles to the east of Savunga. And then late last month into early August, there were a report of marine debris as well associated with dead birds. And so I'll briefly touch on that. But as of right now in 2020, we've had at least 170 reports of dead birds, essentially 170 counted carcasses. And so why are birds starving? Again, it's only with partners helping us collect these data and this information, but the warm water effect, so that's both, as I mentioned, the increase in metabolic rate, but also competition with predators, that warmer water redistributing or affecting the distribution of prey items, as well as the abundance of forage fish. And again, to emphasize the direct competition with the biomass increase of cod and pollock in the Bering Strait is not helping either. And then the warmer water, harmful algal bloom events happening more frequently, but we really don't know how that affects the prey either. Does it affect their distribution? Does it affect their survival? And so that could be another factor limiting food for marine birds. And then again, these numbers here, you know, we're really asking community members to report any observations of unusual sightings, whether it's some clear gelatinous oil, seabirds, or even dead forage fish washed up on beaches. Every little bit of information and remaining vigilant is really helpful. And so partnering, we work with the Coastal Observation Seabird Survey team based out of University of Washington, as I mentioned, and have a strong citizen science presence in Alaska, but of course that's mostly the roaded system of Alaska. So They did come up with, instead of just doing their monthly surveys, which provide a baseline, what's a normal number of birds washing up on your beach, to a die-off alert protocol. So during the last couple summers with these unusual mortality events, getting a way that you can at least quantify the number of these birds by monitoring or counting a certain stretch of the beach and coming up with an estimate of dead birds per kilometer. And then again, the USGS National Wildlife Health Center continues to support the determining cause of death, and also looking at parasite load and infectious disease, which we really we need to rule out infectious disease right away to make sure that no ramifications from that. And then Dr. Caroline Van Hemert, she's at USGS Alaska Science Center. They've started a harmful algal bloom testing lab. And so all of our carcasses that we get from the coastal communities going to the National Wildlife Health Center, they collect stomach, intestines, part of the brain and breast muscle and liver. Unfortunately, to test for harmful algal blooms, the best tissue is the stomach with the food that they consume, but because seabirds are starving, there's very little material to test. So they started looking at liver, the medulla oblongata in the brain, as well as breast tissue. So, and Bob Dusick at USGS National Wildlife Health Center is looking at effects that exposure to saxotoxin have on birds, their behavior, the residual time, how long that saxotoxin known dose resides in the tissue. And this is all helping us identify what we are finding based on these carcasses that are getting, wild collected carcasses, providing some measure of exposure to saxotoxin. And then the last bullet being that continuing to work with our partners in the coastal communities. Alaska Sea Grant has been huge in helping organize, get reports, as well as get carcasses for examination and testing. And then trying to reach out with other partners, state, and then tribal folks as well. So the future direction, unfortunately, COVID-19 has stymied a lot of the saxotoxin work that we're doing with our partners. They were interested in looking at physiology and bird behavior. Part of this was working with Alaska, the Alaska Sea Life Center based in Seward. But all of that's been put on the back burner for now and is pending. So, and then waiting to get samples into the lab in Anchorage to test for concentration levels of saxotoxin has been delayed. But Matt Smith, Caroline Van Hemert, and Sarah Shane are kind of the points of contact for this and are eager to get into the lab and determine levels of saxotoxin in these birds that we're getting here in 2020. And then this is my Gnome Nugget, oldest newspaper. This is my shout out to the Gnome Nugget. And Gay Sheffield has really helped spread the word of what the Bering Strait region, and one of these was sending the Gnome Nugget, where Lyle Britt from NOAA had done a presentation, a Bering Strait science presentation at that, and really found that lack of sea ice, no cold pool, is having profound effects on the biodiversity and biomass, with cod and pollock moving further north than had previously been recorded. So very eye-opening, and always appreciate getting the inside scoop from Gay as well as the Gnome Nugget.
Well, on this one, I'm going to speak up on this one. This was actually Lyle Britt broke this story in the Gnome Nugget. This is probably one of the biggest stories that to affect sort of everything that's gone. And I just want to say that was here in Nome. That was Nome based when that story came out. That was, so go Nome. Thanks.
Yeah. Go Sandra, go Gnome Nugget, go Nome, absolutely. And go Gay for getting Lyle in to break the story. So yeah, this is a figure I try to use regularly because I think it's it's jaw dropping to see this level of biomass increase. Yeah, it leaves an impression. They tell us not to use words like unprecedented, but here you see in the slide, it's unprecedented. The near lack of, or unprecedented with the near open water. And then also from Gay, she sent this, I think this was from December. Okay, this is from November. I got it from Gay and actually used it at a leadership meeting for Fish and Wildlife. And it really emphasized to our regional director, for example, the increase in fishing activity that's occurring in the Bering Strait region. And so this was actually from the Coast Guard emphasizing their lack of being able to do a search and rescue response in this region. And, you know, it very clearly, you know, brings home the message that there is a lot of vessel traffic, fishing activity now following the cod and pollock further north. So thanks again to Gay for sharing this. This made me look really smart at a meeting, or at least I felt really smart. Cutting edge, thank you, Gay. Oops, I went the wrong way. And so this last couple slides here, this is a non-petroleum oiling event in Savunga, and it's a text-heavy slide, but I wanted to make sure that I didn't forget anything, and that if people wanted to look back at this later, that all the information was here. But essentially on the 17th of June, there was a report of some oiled birds, and the oil turned out to be a clear waxy material. And the figure on the right is a chromatogram, and that's looking at the signature of the oil. And so the very top indicates the fingerprint of what a spilled crude oil would look like. And so they determined initially that this was not a petroleum product, but instead either vegetable or fish oil. And next steps were to essentially, well, Louisiana State University runs the lab to fingerprint crude oil, and that's why this sample was sent to Louisiana State. Next steps were to find another partner that might be able to determine whether this is fish or vegetable. So these next steps here, one is to re-emphasize that you're not allowed to put anything over the side of your ship. Fryer oil from your French fryer or fish processing. And so outreach, maybe this is something to re-emphasize to the Coast Guard and everybody. The education and outreach is really important to remind partners that are, you know, folks using the marine ecosystem, that you cannot put things over the side and that they have effects and ramifications for the wildlife and for the people in the Bering Strait region. And so next step right now, Texas A&M has said that they'll be able to take a look at this chromatogram and determine whether it's fish or vegetable base. And again, kind of working with our Bering Strait partners to get that information back and continue to collect. If this type of event is happening more frequently, it'd be, you know, we really need to keep an eye on how frequent people are seeing this type of oiling event, which unfortunately, as it's not a petroleum based, it falls into an unusual, we don't have, you know, the Coast Guard resources because it's not petroleum, but they of course are concerned as well. So working on continuing to track this down and then report back to the communities as we get more information. And so additionally, with that increased vessel traffic, Gay made us aware, Ben Pangawe from Savunga had been over to a fish camp, and I think on his way back about 18 miles to the east of Savunga, encountered dead seabirds, looked like fulmars, and then a pulse of consumer debris, as it was called. And these reports were also being coming in from other parts of Norton Sound, and then Austin, Amisoc also did a ATV cruise up to the North Sinac River and documented a lot of trash. And as you can see, that there's a lot of water bottles, but there's also some, you know, and these photos are from Austin and Gay, but compiled a lot of water bottles, but some of it butane, some of it penetrating oil, really not good things. And of course, you can see that the writing is not US writing on these. And so that increased vessel traffic, I think it's important to somehow outreach and make sure that they understand are folks that are fishing on the other side of the EEZ that they know not to be dumping. And really this has an effect. So Ben coming back from his fish camp, I mean, this is getting into fish nets, and it's just, well, besides just being disgusting, it's just kind of disappointing. We did have a call with NOAA Coast Guard and other folks, state DEC, and there was an idea that perhaps hindcasting, where you take the known ships using the Automated Information System, AIS, you might be able to pinpoint back to a vessel that was in that area. It is very challenging given currents and wind, and really not knowing how far, for example, a plastic bottle or a spray can of penetrating oil will travel in the wind, and not having an exact time when Ben went by. You know, did Ben go by on a Thursday, and then when he passed back by on a Friday, suddenly there was all this trash. And so working next steps are trying to develop a hindcast model, but as well as work with communities to get that better information, and hopefully get some answers and minimize the number of the amount of trash. So it's an active effort right now with a lot of partners as well.
And if I can just jump in for a sec, Rob, this is Gay. For the trash, for people from Nome, so Austin went from Cynic River back to Nome and had 124 different items, and he picked up about 75 items that he had some trash bags, and we went through each one, and it was shocking. I did not realize that Nome Eskimo community has a marine debris program and has been cleaning certain beaches, which is great. But in 4 years of doing this, they found one Coke bottle with Russian writing on it. So if that gives you an idea of, like, this was sort of a large amount for here, and then it's sort of spreading around as it gets flushed through the system. That's it. Thanks.
Yeah, thanks for that, Gay. Right. I think, you know, some of the initial questions were, well, is this unusual? And it's like, yeah, but that's really, having that baseline information to say, yeah, this is unusual. And then the AtSea surveys that I mentioned earlier also track marine debris that's observed during the marine bird and mammal surveys. So there are some of those data available to help document baseline levels of trash. But this definitely is something that needs to be addressed, and education is probably going to be a little challenging to our friends across the Bering there, but something that we need to strive for. But anyways, I want to just quickly mention that the next actions include trying to hindcast back to where these might have evolved or come from, but as well as help continue to track reports as they come in for, hopefully this doesn't continue, but again, going back to remaining vigilant, both if you see something unusual, please report it. And with that, this is my last slide. This is the please report. We work with the Alaska Migratory Bird Co-Management Council. The names that I've listed here and phone numbers are trying to provide a regional place that people can provide observations of dead and dying birds, but marine mammals, trash, anything that's unusual. We also try to work with the LEO network, Local Environmental Observing Network, with the Native Health Consortium, and then all of our other partners as well. Alaska Sea Grant, again, has been a huge partner in tracking these events in the Bering Strait. And with that, I guess I'm going to thank you and perhaps let Gay get to her T-bone steak.
Can we ask questions?
Thank you, Rob. I don't know how we in the virtual world, but yeah, let's start off with questions. And Rob, if you can, I'm not sure, maybe let's wait to your questions before you stop screen share, because people might want to go back and look at your, look at some of your slides. Go ahead if anyone has questions.
Molly, my wife asked one in chat.
Oh.
Why don't you read it?
I can read it out loud. It says, Does the age
You're
slash
asking.
state of the debris give you any insight about how long and the effects of those bottles on the water slash marine animals?
Ah, that's a good question. You know, I don't know. Marine debris is not my specialty, but it did look like some of those bottles had been floating on, getting beat up for a little while. I don't know if, Gay, you have a good response to that, but a lot of it looked, yeah, I'm not sure the degradation, how long it'll float around for, and then get beat up on the beach. Yeah, so I don't actually have a good answer for that. I don't know,
So
Gay?
just off the top of my head, again, marine debris is not my thing, but a lot of the plastics were kind of crinkled up like they'd been in the trash, somebody's trash. And there were some expiration dates, like on the milk, right? And on the milk jugs and the some of the other, they had like these small plastic, like almost like a yogurt drink thing, raspberry, watermelon. Anyway, and they had expiration dates that were right now, so it looks like it was pretty recent. And it all came at once, and this is not a talk on debris, but know that it has hit several of our villages, and it's tracking right through the strait, you know, Wales, Naushish, you know. So it's moving on up, and that's where you were talking about the current. If that answers that one.
Yeah, I was wondering if you'd heard anything from Little Diomede.
The current's so fast there, not a lot of things typically stick, and they don't really have beaches. Like you would think it's just cliff. Most part.
Must be why there's so many auklets there.
Maybe.
Can you talk a little bit more about the particular toxin? I didn't really understand what caused it or what it does. The like SVT.
Oh, the saxotoxin?
Yeah.
Yeah, so saxotoxin is associated with paralytic shellfish poisoning. STX is the handy abbreviation for it. It's a neurotoxin, so it affects the way the brain works, which is one reason that we've been pursuing it as a potential contributor to seabird die-off, because it could affect both how the predator, you know, pursues its prey, but as well as how the prey behaves too. So one of the things that USGS National Wildlife Health Center has been looking at is how there's an idea, and it's hypothetical right now, but the digestive enzymes of birds actually make them more susceptible to the effects of a saxotoxin neurotoxin. And so if they consume a tainted fish, say a capelin or a sand lance, they appear to get very sick, and this was a captive study using a flock of mallards in Madison, but a no-one dose wiped out the entire first round of captive birds with the exception of one female. She lost a lot of weight, she became very dehydrated, and so if she got better 24 hours later and then consumed another tainted item, you know, these birds already toe the line on their metabolic rate. So if they get sick 24, 48 hours, now they're dehydrated, that can be, you know, push them over the end. And then I always mention, and I think it's usually a Tuesday or a Thursday, but there's a storm system that comes through, and that's, you know, so birds that might already be compromised, then you get a wicked storm, a 968 millibar low or whatever, and that just is the tipping point. And so then you do have these huge fluxes. So that's an answer to say, we think saxotoxins could be affecting their behavior in many ways, and then insult to injury with like a weather system and a lack of food. Did I answer that?
I guess I'll just jump in a little bit and just say saxotoxin is produced by an algae. It's naturally occurring poison that comes from an algae called Alexandrium. That's the genus. And we have in the Bering Sea Alexandrium all the way up to actually into the Chukchi Sea, all the way that we're aware of into to Utqiagvik. I don't think anyone's looked for it in the Beaufort Sea, but I wouldn't be surprised if it's there. Typically low level. So we have low levels of it, big deal. Low levels don't do anything. But if you get to high levels, if you get to where the conditions are right for algae, and we all like algae, algae is a good thing, except there's certain types that produce this incredibly strong neurotoxin. So if you eat something, paralytic shellfish poisoning, if you eat a clam that has been filtering seawater that's in an area where you have what's called a bloom, and a bloom is just uncontrolled growth of algae when conditions are right, takes off and multiplies. So if all of a sudden you're a clam and now you're surrounded by this kind of algae, you're going to be sucking in a lot of saxotoxin, and you're a clam. You don't care. But if you're a person or a mammal, seabird, you do care, and it will go straight from your gut into your bloodstream and head right for your brain, and it will, it paralyzes you. And so you look for some of the things, like if animals are acting lethargic. The animal was so tired, you know, well, he's so tired because he's like, I want my wings to fly, but nothing's happening. And so that's what happens with people. And we just recently had Alaska's first fatality in, like, I don't know, 10 years for paralytic shellfish poisoning. This poor woman ate, she went July 4th weekend in Alaska. So this is our first Bering Sea. Yeah, it's down there, but Bering Sea documented fatality. She goes down, picks up some blue mussels and some snails or something, has a nice July 4th picnic with her family, but she dies in Anchorage I think it took a day. Horrible. And now, you know, what sets off Alexandrium? Because we have it. What sets it off to grow out of control? They don't really know the trigger, but you need lots of nutrient-rich water. We got that. Lots of sunlight. Today we have that. And warm water, and we're getting that. We have that, actually.
Yeah,
so,
can you mention the cysts as they serve? Like, it sounds like there's a whole seed bed in the northern Bering.
you want me to guys really cheer everyone up?
They have beer. They're okay.
No, I don't know about the others, but so cysts are saxotoxin, or Alexandrium will make cysts when it's not doing so great, and it just goes down to the bottom, right, of the ocean and sits there, and it's viable for over 100 years. And so as the currents have been pushing this stuff and pulling it up into or shunting it up into the Chukchi Sea, those little cysts are just deposited up. Turns out, you know, on the backside of St. Lawrence Island, you have an eddy, right? So stuff falls out there. On the backside of north side of Point Hope, that's where they've just found there's actually in the Chukchi Sea, I think the world's highest level of Alexandrium cysts that have just been settling out, waiting for conditions to be just right. And we're not there, but it does make you think. Yeah, I can tell you guys are cheered up.
Yeah, that's great. I'm all about the cysts.
Okay.
How can you talk a little bit about what role do seabirds play in the larger ecosystem, and what effect would we see if the die-offs, these mass die-offs of seabirds continue to happen?
Yeah, I did think it was interesting. So I think this is RB.
This is, I think, Vince and Carl.
Yeah.
Oh, Vince and Carl? Oh, well, I guess it doesn't matter. Oh, hey. Well, anyways, so the earlier slide were kind of demonstrating that seabirds are indicators of the, you can only die one time, as it turns out, or so I'm told. And so when, showing the Alaska Maritime report card that demonstrates productivity actually increased in 2019, but that was after several years of pretty big failures reproductively, and then emphasizing that these birds, because they're long-lived and slow breeders, in terms of coming to maturity, getting one egg per year, and then actually having that young bird that fledges the nest or ledge or burrow, recruit back to the population. So going back to that, you can only die one time. I am concerned that without continued monitoring, and 2020 is a terrible year due to the COVID. So we really don't have any information on reproductive success for MERS. auklets. You know, we are really going to rely on reports from the communities, observations. You know, what did you see at Sledge Island? What did you see at your local colony? Did it seem unusual, more birds? And it's a little more difficult, you know, to come up with that, you know, cute graphic with smiling eggs or cracked eggs. But it's, yeah, so continuing to monitor seabirds really help us keep a finger on the pulse. The Bering Strait region, I think, showing those currents, you know, what happens in the Bering doesn't stay in the Bering. So as birds move further north, as we track these changes in distribution, but also decrease productivity, or in some years where shearwaters die off in, you know, mass numbers, yet productivity for these, the auks are doing okay. The more information we have, and again, we rely on a lot of that information from communities as well as the federal agencies. So I don't think I answered your question, but I don't actually have an answer. Why do we continue to monitor seabirds? As a proxy to the ocean, health of the ecosystem, and really remaining vigilant. So as these changes continue, we can at least try to work on answers, track harmful algal blooms, or, you know, direct competition for with other predators and marine mammals as well.
Hey, Rob, can you stop your screen share so we can see you too? That'd be good. Thank you. I was going to say, and because the seabirds are an essential food resource up here too. I hope that's why you would want to monitor.
Yes.
And
security.
Anyone else have a question? I have a question, but I'm going to let everybody else go before me. Anyone? Okay. So on the back of the envelope, thank you so much for providing this presentation and letting us talk about seabirds. You had a great slide with 2015, you know, don't pull it up, but you had the numbers. You had the 2016, 17, 18, 19, whatever, and you had what the results were. And I was interested in that. And I was kind of like on the back of the napkin doing it. About 75% of those birds have died of starvation, right? But we don't have the saxotoxin analyzed, especially now because of this, all the labs are closed. So that's too bad. But starvation has been a huge, big thing. We've had this big, massive influx of the fish, which you pointed out from Lyle Britt and the NOAA Race Division fishery results, the trawl survey. And they can't come back up this year because they can't do their research, but that's all right. We'll figure it out. They'll come back hopefully next year. So we know we're beset with predators from the south. Pollock, big predatory fish, commercially viable, Pacific cod, and all our, you know, crab have kind of tanked, and then all the little Arctic cods have tanked, and then the smelt have tanked. Is there going to be a time when Fish and Wildlife might say, or somebody might say, it isn't disease, it isn't saxotoxin? We can't say that yet, but it's our ecosystem up here. Is that what it's looking like? Is that what people are kind of thinking about for the seabirds? I don't know what the kind of the scuttlebutt is on.
Yeah, well,
the starvation might be attributed to.
It's all connected. I follow Rick Toman. I listen to the patterns that him and I think Brian Brett Schneider, you know, talking about the climate patterns and what is being experienced in the Bering Strait in particular. Lack of sea ice. You know, I have a whole series of presentations where I went to the National, you know, Snow and Ice Center, but it's so depressing. I quit using those slides. Just lack of, and then, you know, January 2020, there was a cold spell and everybody was very optimistic. But of course, that ice is, you know, that's young ice, 1 to 2 year old ice, not as nearly robust as a 3, 4, or 5 year old ice. And so will Fish and Wildlife Service ever admit that that seabirds are, you know, declining rapidly? You know, the idea is that animals will adapt to a change in environment. You know, I've studied kittlets as merlets, and they're an ice obligate, but and often I have a figure that shows that over the last 20,000 years, you know, the Bering Strait, it's a nice 1,000 year block, but it shows that the Bering Land Bridge, of course, it's not a bridge at all. It's a huge swath of land that connected two continents, 80 miles wide by 600, miles. And so the idea that a species like the Kittlitz's merlet have evolved to adapt to, change in climate, but the concern being that is change happening too rapidly for animals to evolve and adapt to it? And I gave a presentation to the OLE folks, which is our extended learning adult folks here in Anchorage. And even these guys who, most of them are retired, 50s, 60s, you could see that I was just depressing the heck out of them. And so remain vigilant, and I think I learned that from you, Gay. Continue to monitor these events, continue to coordinate and communicate to the communities, into the regional hub, and to the rural and back into Anchorage. And so at some point, will we all give our, I hope not. You have to be hopeful, but I don't have children, so I'm a little depressed.
Well, don't be depressed, but one thing is, from an ecological standpoint, this region, the Bering Strait region, is incredibly important as a breadbasket for producing zooplankton, and we produce high amounts of algae. We produce which in turn produces high amounts of zooplankton, which in turn, and we have this incredible ecosystem up here, and it just seems like we're getting beset with issues that are maybe saying something about the entire ecosystem, with our seals and our seabirds. So I don't know how wildlife looks at that, but thank you.
Yeah, well, and it's partnerships with you, Gay, for example, that helps. Of course, I gush about how great Gay is. I think we all know that. I learn a lot from Gay about what's happening, and so many of my slides are from Gay. Thank you, Gay.
All right, that's thoroughly embarrassing. All right, I thank you though. And any other questions for Rob? No. All right, with that, thank you. They're actually, thank you very much, Rob, honestly, and we really appreciate it.
I appreciate the invitation.
Yeah, we can clap virtually. Oh, look at RB, he's got it. He's got a clapping thing. Also say something nice there. There he goes. All right. Oh, everyone's on it. Very nice. And there's also the chat. If you want to drop Rob something, a little chat, you can also do that. I keep forgetting to check that. With that, I will say thank you all for coming. The next Straight Science looks like it may be as early as the 19th, where we have Jackie Grebmeyer talking about some of her oceanographic work. She actually will be, I think she's going to be on a ship, the Oscar Dyson. And in September, if you're interested in birds, we're going to have September 3rd. There's going to be a talk about an Aleutian an Aleutian Tern project. And that's what's in the lineup for right now. With that, thank you all for coming.